This video is going to be just a quick recap or a rundown of section 30. So hopefully you've already gone and watched the quiz video for section 30. Essentially, it just talks about imaginary numbers. Okay, imaginary numbers are anything that involves the square root of a negative. So the square root of -1 is an I. If you did something like the square root of -4, that would be the square root of 4, which is 2, and the square root of a negative, which is I. Now, those imaginary numbers can be brought together as a complex number. Okay, and a complex number just has a real part plus an imaginary part. Every number that you've ever dealt with has been a complex number that has 0, I, as the imaginary part. So you've already dealt with complex numbers, you just didn't know it. We always dealt with just the real part of the complex number. Okay, so from there, knowing that an imaginary number is the square root of a negative, and you can go really deep into detail of all the things that they mean. Imaginary is not the best word for what these are because they actually do exist. They exist on planes, like coordinate system planes, and can have actual value to them. But when imaginary numbers were being invented, I think it was Rene Descartes, he was making fun of them a little bit and used the word imaginary for them. So it stuck. So we just call them imaginary numbers. Okay, so let's look at the things that we can do with complex numbers. Okay, while I'm doing this video, you probably notice I sound like I have a cold. It's actually COVID, so that's why this video is taking so long to get out. Hopefully it gets to you before it's too late. Anyway, okay, so our complex numbers, we can add complex numbers. So if I have 4 plus 5i plus 7 minus 10i, I could just add those complex numbers by adding the real parts together and the imaginary parts together. 5i plus or minus 10i is -5i. And that is our answer to the addition of the complex number. Now we can also subtract. We can subtract the complex numbers. So we have 3 minus 4i minus -3 plus 12i. Okay, and we want to add these together. You will want to distribute the negative through, so that's a plus 3 minus 12i. So we end up with 6 minus 16i. So there we go. That is adding or subtracting complex numbers. Now that's not terribly difficult. It's just exactly like what we did with polynomials. Now let's look at if we were to multiply complex numbers. Okay, if we're to multiply complex numbers, there's one thing that you need to know. So if I have the square root of -1 and I square that, the square root and the square here actually do equal -1. Because I'm not squaring the inside, I'm squaring the outside. So the square root of -1 is -1. Okay, so that means if I have I, which is also -1, and I go I squared is -1. This is a huge concept with complex numbers, that I squared is -1. That means that I squared reduces to a number that is not imaginary anymore. Okay, so with that in mind, let's multiply. We'll just go right to a foiling. 3 minus 7i times 4 plus 2i. If we were to FOIL this, we have 3 times 4 is 12. 3 times 2i is 6i. Negative 7i times 4 is negative 28i. And hopefully, if I make a mistake, you will be forgiving of me today. Negative 7i times 2i is negative 14i squared. Okay, if we were to simplify this, we can go 6 minus 28 is negative 22i. But then I can go and write I squared as negative 1, which means that this is a plus 14. Negative 14 times negative 1 is a positive 14. So 12 plus 14 is 26 minus 22i. So that is our multiplication of complex numbers. I actually want to show you one more multiplication. If you remember, our square roots, when we multiplied numbers that were the same but opposite, those were called conjugates of each other. When we multiply numbers that are conjugates with our square roots, the square roots went away. Well, turns out imaginary numbers are just the same thing as square roots. They're just square roots of a negative. So when we multiply complex numbers, that the imaginary numbers, are going to go away because these cancel, and I squared is negative 1. And negative 4 times negative 1 is positive 4, so that ends up being 20. So just like square roots, they have imaginary numbers or complex numbers also have their conjugates. Okay, and so when we multiply the conjugates, they go away, which is kind of cool. So let's look at that in an application. Okay. So this is going to be division. With imaginary numbers, we do not like having any imaginary number in the denominator. Okay. This is very important because this is going to be similar to what is on the test. It's going to say divide, and it just gives us something like this. And in order to make it so that we can divide, we just are going to multiply the top and the bottom by the conjugate of the denominator. Exactly like when we were rationalizing the denominator. That's what we're doing here, is rationalizing the denominator. So if we multiply the top and bottom, we distribute the 4, that's 12, minus 8i. And then we distribute the bottom, let's see, that's 9, minus 4i squared. So that gives us 12 minus 8i all over, this is 9 plus 4, so that's over 13. Now, there's one last little thing you need to do here. This is kind of the special thing. You want to write your final answer so we're going to write the final answer as a complex number. So that means that we need to take this 13 and divide it into the real part and the imaginary part. So that means 12/13 is our real part, and negative 8i over 13 is our imaginary part. We can't write our number as a complex number when it was written in its original form. But whenever we have an imaginary number in our expression, we want to write that expression as a complex number. So we multiply the top and bottom. All right, so that's pretty much the entire section. I am going to finish off by doing one more division problem just so you can see that. But if you're feeling comfortable, you are more than free to stop there. Okay, let's make this one just a tiny bit harder. 4 minus 2i over 6 minus 5i. So I'm going to multiply the top and bottom by the conjugate of the bottom. So that would be 6 plus 5i, 6 plus 5i. Okay, I'm going to FOIL my numerator. That's 24 plus 20i minus 12i minus 10i squared. And in the denominator, I have 36 minus 25i squared. So I'm going to combine like terms. I have this minus 10 times negative 1. That's like plus 10. So it's 24 plus 10 is 34. 20i minus 12i is 8i. I hope. Just kidding. And then 36 minus 25i squared is like plus 25, because that's minus 25 times negative 1 is a positive 25. So 36 plus 25 is 61. Okay. Then we just rewrite the real part, which is 34 over 61, plus the imaginary part, 8i over 61. And with this, we look to see, can any of them be reduced? If they can, reduce it. But if not, that is your final answer. So there's a quick rundown of how to work and deal with imaginary numbers and what they are. If you're still confused about what an imaginary number is, I recommend going back and watching the quiz video for section 30. That should be a big help to give you all the information of exactly what the imaginary number is. Good luck!